Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Bronsted acid strength depends on the stability of the conjugate base formed after proton donation. A stronger acid has a more stable conjugate base. Moving on to the next step. Identify the acidic proton in each compound. A. Aniline, PHNH to NH bond. Aniline is a very weak acid, pKa 30. B. Cyclohexylamine, CYNH to NH bond. Aliphatic amine is an even weaker acid, pKa 35, because no resonance stabilization of conjugate base. C. Cyclohexanol, CYOH-OH bond. Aliphatic alcohol, pKa 16. D. Phenol, PHOH-OH bond. Aromatic alcohol, pKa 10. Moving on to the next step. Compare OH acids versus NH acids. Oxygen is more electronegative than nitrogen, so OH bonds are more acidic than NH bonds in general. This immediately eliminates A and B as the strongest acid. And for the final step, compare phenol, D, versus cyclohexanol, C. Phenol's conjugate base is the phenoxide ion, Pho. The negative charge on oxygen is delocalized into the aromatic ring through resonance, generating 5 resonance structures. This extensive resonance stabilization makes the phenoxide ion far more stable than the cyclohexide ion, which has no such delocalization. Cyclohexanol pKa 16, phenol pKa 10. A lower pKa means a stronger acid. Why other options fail? B. Cyclohexylamine, NH acid, no resonance stabilization, pKa 35, weakest acid. A. Aniline, NH acid, some resonance but nitrogen is less electronegative, pKa 30, still weak. C. Cyclohexanol, OH acid but no resonance stabilization of conjugate base, pKa 16. D. Phenol, OH acid with resonance stabilization of phenoxide conjugate base, pKa 10, strongest. Therefore, the correct answer is D. Therefore, the correct answer is option D.